अस्सलाम वालेकुम स्टूडेंट्स। आज हम टेंजेंशियल एंड नॉर्मल कंपोनेंट्स ऑफ वेलोसिटी एंड एक्सेलरेशन पढ़ेंगे। इससे पहले हम कार्टेशियन कंपोनेंट्स एंड रेडियल एंड ट्रांसवर्स कंपोनेंट्स ऑफ वेलोसिटी एंड एक्सेलरेशन पढ़ चुके हैं। नाउ इफ अ पार्टिकल P moves from the point A to point B through this path, so this path is called the trajectory. अब अगर वो पार्टिकल हमारा इस पॉइंट P पर है तो we can specify the position of this particle through this vector R. और अगर वो पार्टिकल यहां से मूव करता हुआ पॉइंट Q तक चला गया है तो ये जो हमारे पास कॉर्ड है PQ, this can be represented by del R. Now the position of particle at point Q can be specified by R plus del R. And this arc, which is PQ arc, can be represented by, you can say that's arc PQ is equal to del S, and this PQ vector is represented by del R vector. Now the vector V can be written as dr by dt, which is the instantaneous rate of change of displacement. We can write this as dr by ds and ds by dt. Here ds is the distance on the curve at any time from the fixed point. Now this ds by dt is the rate of change of displacement with respect to time, so this is equal to v, the velocity. So vector v is equal to dr by ds dot v. Now as we know that instantaneous rate of change of displacement, when we write it at dr by dt, तो इसको हम लिख सकते हैं कि limit del t approaches to 0, change in displacement and change in time. So similarly we can write dr by ds is equal to limit del s approaches to 0 del r by del s, which shows that the direction of dr by ds is along the tangent to the path at the point P. So which shows that the direction of dr by ds is along the tangent to the path at the point P. So let t unit vector be the unit tangent vector along the tangent to the curve at P. Now we need to calculate the magnitude of dr by ds, which is equal to limit del s approaches to 0 del r change in displacement and change in speed, which is limit del s approaches to 0. This del r is the length of the card PQ, this PQ length. So this is equal to length of card PQ, and this del s is length of this arc del s, length of arc PQ. अब जब हमारे पास ये del s कम से कम होगा, अप्रोच कर रहा होगा 0 को, दैट मीन अगर हमारे पास Q यहां पर होता तो ये हमारे पास कार्ड होती और ये हमारे पास आर्क होती। इन दोनों की जो लेंथ में फर्क है वो इसकी निस्बत कम होता। उसके बाद अगर हमारे पास ये पॉइंट Q यहां पर होता तो इस आर्क और इस कार्ड के बीच का डिस्टेंस मजीद कम हो जाता। इसी तरह जब ये del s अप्रोचेस टू 0 होगा तो हमारे पास दोनों की लेंथ बराबर हो जाएगी, which means this should be equal to 1. Now the vector is all about the direction and magnitude, so इसका magnitude हमारे पास 1 है और direction हमारे पास इसकी unit vector t है। So this is equal to unit vector t. अब हम dr by ds की वैल्यू यहाँ पर पुट कर सकते हैं यहाँ पर। So v वेक्टर हमारे पास t unit vector v होगा हमारे पास। Hence v vector is equal to v into t unit vector प्लस, अब नॉर्मल वेक्टर हमारे पास यहाँ पर 0 है। नाउ दिस dr by ds is tangent at the point P. अब अगर हम इस टेंजेंट के ऊपर एक लाइन ड्रॉ कर लें जो कि इसके परपेंडिकुलर हो तो वो हमारे पास इसका नॉर्मल होता है। दिस इज द नॉर्मल वेक्टर एंड दिस इज द यूनिट वेक्टर t. Now the unit normal component is 0 and unit tangent component is v. So हमारे पास इसका tangential component of velocity is equal to v है और normal component of velocity is equal to 0 है. Now we have to find the normal and tangential component of acceleration. We have derived that v can be written as plus 0, which is in fact, now acceleration is equal to the derivative of velocity with respect to time, which can be dv by dt, v t unit vector. So we can write this as dv by dt and t unit vector as it is, plus dt by dt and v as it is. Now we have to find the magnitude and direction of this dt by dt. As we know that dot product of unit vector with itself is equal to 1. So differentiate with respect to t will give us dt by dt plus dt over dt into t vector, and derivative of 1 is equal to 0. Now we can write the above as dt over dt, t unit vector is equal to 0, and dt over dt is equal to 0. Now this t is a unit vector along the tangent line, and its dot product with dt over dt is equal to 0, which means dt over t is along the normal to the particle at point P. Unit tangent vector at the point P is t. Then एक लाइन जो परपेंडिकुलर हो t से वो हमारे पास नॉर्मल वेक्टर है, और इन दोनों का हमारे पास जो डॉट प्रोडक्ट होगा वो 0 होगा. So this dt over d, direction of dt is along the normal unit vector. Now we have to find the magnitude of this dt over dt. So limit del t approaches to 0, this del t over del t. Now we can see that कि अगर हमारे पास ये पार्टिकल पॉइंट P पर था, हमारे पास ये पॉइंट Q पे मूव किया, और देन हमारे पास जो कार्ड होगी वो PQ है और आर्क हमारे पास ये PQ है. लेट्स से अगर हमारे पास ये एंगल है साई, अगर पॉइंट Q पे कोई टेंजेंट है हमारे पास, angle between them is del psi. Now this can be written as dv by dt, t unit vector, plus change in the unit vector t. चूंकि हमारे पास ये t जो है ये हमारे पास एंगल में आ रहा है psi का, तो हम इसके लिख सकते हैं change in unit vector divided by change in the angle psi into change in the angle psi with respect to change in the distance, and then change of distance with respect to change in time. Now we know that ds by dt is equal to v, so this can be written as dv by dt unit vector t plus dt over d psi over ds and v. Now d psi by ds is actually the change of angle with respect to this change of distance. So we can write d psi by ds is equal to curvature into velocity, so where k can be written by v, which can be written as 1 over rho v. This rho is the radius of curvature. 1 plus dy by dx square power 3 by 2 divided by second derivative of dy by dx. So the above expression can be written as dv by dt t unit vector plus dt by d psi into 1 over rho into v square. Now we are left with dt over d psi. As we know that t can be written as, t is a unit vector, so it can be written as cos of angle here is psi, so cos of psi I plus sine of psi j. Now the unit vector n, इसका एंगल हमारे पास बनता है, अगर हमारे पास ये परपेंडिकुलर हो तो हमारे पास इसका एंगल बनता है 90 डिग्री, and this is greater than 90 degree, then the angle is 90 plus psi. So unit vector can be written as cos of 90 plus psi I plus sine of 90 plus psi j. ट्रिग्नोमेट्रिक एक्सपेंशन से जब हम इसको ओपन करेंगे तो दिस विल बिकम माइनस साइन ऑफ psi I plus cos of sine j. Now dt by d psi is equal to minus sine psi I plus cos of psi j, which is equal to unit vector n. So this expression, which we can write 1, can be written as a unit vector dv by dt is equal to dv by dt unit vector t plus 1 over rho v square and unit vector, which means the tangential component of acceleration is dv by dt and normal component of acceleration is 1 over rho v square. So these are the tangential and normal component of acceleration. Thank you very much.